Okay, new topic, parametric equations. So make some notes on our heading and lesson objectives. When you're ready, hit play again. Right, so when we're defining our x and y coordinates, which we can call Cartesian coordinates, so there's a different name for them, we can write them in terms of a third parameter. So your x and y coordinates, we can write them in terms of this parameter. Often t is used. So you can say x is a function of t and y is a function of t. Right? Often used in physics when they resolve forces. Right? And t is chosen because it often represents time. So let's have a look at writing x and y coordinates in terms of a third parameter, t. So an example for us here. In this example, we want to draw the graph of a function x equals 2t and y equals t squared between the limits of -3 and 3. Okay, so we're trying to draw that between those limits. So two ways of doing it. The first one you're very familiar with. Set up a table from -3 to 3. So there we are. There's our t from -3 to 3. We know that x is equal to twice t, so we just double each term there. So x is equal to -6, -4, -2, and so on. And y is given by t squared. So we just multiply by itself. Gives us 9, 4, 1, and so on, and then we repeat. Now looking at that, you can see it's quadratic. Always, and it's a happy curve, always stays above the x-axis. When we sketch it, it looks like so. A nice happy quadratic. So that's your x equals 2t, y equals 2t. Now we can also rewrite this in terms of x and y and then sketch the curve. So let's look at doing that then. So in terms of x and y, we've got here that x is equal to 2t. I can rewrite that as t is equal to x over 2. Okay, now y is equal to t squared. But I know that t is equal to x over 2, so that means, or that implies that y is equal to x over 2 squared, which is equal to x squared over 4, which is our quadratic equation, which we could sketch as we did earlier, giving us exactly the same result. Happy quadratic. There we go. So your turn, make some notes. So hit pause, make some notes, and then we'll look at another example. Good. Okay, we've got another example. So make a note of the example. We've got a curve with parametric equations x equals the log of t plus 3 and y is equal to 1 over t plus 5, where t is greater than -2. And they want us to find a Cartesian equation. So your Cartesian equation means that we're going to find an equation of the form x and y. So it's going to be defined in the form of, oh, there we are, y equals a function of x. So that's our Cartesian equation, which we're used to. It's just we haven't been using the term Cartesian. Right, and x is going to be greater than k. That's our range. So same as before, x is equal to the log of t plus 3. So we can rewrite that then, taking the exponentials on both sides. So if we reverse the log, e to the power of x is equal to e to the power of log of t plus 3. Now, if you write the exponential and log, cancel each other out, so e to the power of x is equal to t plus 3. Which implies, rearranging, that t is equal to e to the power of x minus 3. So we know what t is. Now we know that y is equal to 1 over t plus 5. So sub for t, and that gives us that y is equal to 1 over e to the power of x minus 3 plus the 5 that we're given there. So y is equal to 1 over e to the power of x minus 3 plus 5 is plus 2. So we've rewritten it then in Cartesian form. There's our Cartesian equation. Now we want to find the limit then. It tells us that x is greater than k. So we want to find out what is k. Okay. Now let's switch pens, use a different color, make it easier to work on the same page. So if I just draw a line here. There we go. So x is greater than k. What's k? Now in the limit, it tells us that t is greater than minus 2. Okay, so if t is greater than minus 2 and you got x is equal to the log of t plus 3, if we sub it in, sub for t, let's just write in the limit then. We sub for t, and so x is going to be equal to the log of minus 2 plus 3, which is log of 1. And log of 1 is equal to 0, so x is equal to 0. That's at the limit. Now, if you recall, which I'm sure you do really well, the graph of log generally looks like, tell you what, we'll do a log of x, or log of t in this case. General graph looks like that, because that's your t and that's your x. But we've got the log of t plus 3, so it's inside the function. So where's that going to lie? To the left or to the right? Plus 3, it's intuitive, that's 1 there. So plus 3 is going to be there. There's your minus 2. So that means as t gets bigger, increases, es, x also increases. And it starts at 0, so x is going to be greater than 0, which is our range. Okay. So we can rewrite that equation there with x greater than k. Right. So now we've got to do section B. And part B of the question says write down the range of the function of f, the function of x. So there's our function, f of x is equal to 1 over t plus 5. So in the limit then, our limit is t is greater than minus 2. What happens to our function? F of x is going to be equal to 1 over minus 2 plus 5, which is equal to a third. Okay. So what happens to this function f of x as t increases? So as t increases, f of x, or y, let's think about it. f of x is equal to 1 over t plus 5. So when t is equal to 1, let's just do a little note here. T is equal to minus 1. F of x is going to be equal to a quarter. So it's getting smaller. If t equals 0, f of x is equal to a fifth. Getting smaller again. T equals plus 1 this time. F of x equals a sixth, and so on. Now it gets smaller and smaller and smaller. It goes towards 0, but never quite gets there. So we can look at our range then. F of x is equal to 1 over t plus 5. And then we know that y is always going to be less than a third. Oops, should I write f of x? I don't want to keep interchanging. Let's just leave it as f of x instead of y. So we can say that the function of x is less than a third, but it's also going to be greater than 0, because it never gets to 0. So that's our range, and that's our part B. So your turn. Make some notes, and when you're hit pause, make some notes. When you're ready, I've got a couple of questions for you to attempt for me. Good. Right, I think on exercise 8a, if you were in class, I would say we'd go down the left hand side of the page, which is fine, but because you're at home and you're really keen and you want to do more, you can do the rest of them as well. You can attempt the rest, but we've got another page as well. So because it's a new topic, it is well worth going up to question 9. Also, I would keep my keep Desmos handy, and as you're attempting the questions, plug in the equation into Desmos so you can see what it looks like, and you can see where the limits lie and where the range is for each question. Okay, good luck.